Hi everyone, I'm Toby. In this video, we're going to talk about derivatives of trig functions. So firstly, let's talk about derivatives of sine x and cosine x. We need to know two limits that are really important for us. The first limit is limit as x goes to 0 of sine x over x is equal to 1. The second limit is limit as x goes to 0 of cosine x minus 1 over x is equal to 0. We're going to use these two limits to evaluate the derivatives of sine x and cosine x. Okay, let's take a look at the sine x first. The derivative of sine x, by the formal definition of derivative, is limit as h approaches 0 of sine x plus h minus sine x over h. We can use trig identity to change sine x plus h into sine x times cosine h plus cosine x times sine h. Alright, let's plug in this expression back into the definition of the derivative of sine x. We can get the derivative of sine x is just limit as h approaches 0 of sine x times cosine h plus cosine x times sine h minus sine x over h, which is equal to sine x, the limit as h approaches 0 of sine x times cosine h minus 1 plus cosine x times sine h over h. We can separate these two terms, so what we get is actually two separate limits. Alright. Given that the limit as x approaches 0 of sine x over x is equal to 1, which means this part is equal to 1 because h approaches 0. So this part is just cosine x. For this part, because cosine h minus 1 over h as h approaches 0 is 0, as shown right here, this part just cancelled, it's 0. So this limit is just cosine x, which means the derivative of sine x is cosine x. Now let's take a look at the cosine x. Okay, firstly, we plug in cosine x into the formal definition of the derivative. Again, we use trig identity, so cosine x plus h is just equal to cosine x times cosine h minus sine x times sine h. Plug that into the formal definition of the derivative of cosine x, we get this expression right here. Again, we combine these two terms to get that term. We separate this limit into two different limits, and we evaluate each limit separately. For the first limit, cosine h minus 1 over h, as h approaches 0 is 0. This term cancel. Sine x times sine h over h, as h approaches 0 is 1. So this term is 1. 1 times negative sine x is just negative sine x, which means the derivative of cosine x is sine x. Alright, we already knew the derivative of sine x and cosine x now, so let's do some practice questions. Pause the video and try that on your own. Alright, did you get the answer? Let's do that together. The derivative of sine pi x plus 2. Let's use the chain rule because it's sine of pi x plus 2 is not sine x, it's some other function in the sine function. So we need to use the chain rule. So firstly, we know the derivative of sine x is cosine x. So this derivative, the first part is just cosine pi x plus 2. Alright, now let's apply chain rule. The derivative of pi x plus 2 is pi. So it's cosine pi x plus 2 times pi, which is derivative of sine pi x plus 2. For this derivative, we also need to use the chain rule. Cosine of square root of pi x. The derivative of cosine x is negative sine x. So we write down negative sine square root of x. But we need to use the chain rule, so we need to multiply by 1/2 times x to the 1/2 minus 1 is negative 1/2. We can rearrange this expression so we get negative sine square root of x over 2 times square root of x. Remember, this two square root of x cannot be cancelled because that one is inside is sine square root of x, just not square root of x, so can't try to cancel them. Alright, the last one is sine square x, which is sine x, the entire thing squared. So we take the we want to take derivative of that function. Then what we do is we take 2 down because the exponent is 2, so it's 2 times sine 2 minus 1 is 1, so it's just 2 times sine x. Remember, use the chain rule. We're taking the derivative with respect to sine x for this step, not x. So we need to take derivative of sine x, which is cosine x, which means that derivative is also equal to sine of 2x by trig identity. Alright, now let's take a look at the derivatives of other 4 trig functions. Other 4 trig functions, tangent x is sine x over cosine x. Cotangent x is the reciprocal of tangent x, which is cosine x over sine x. Secant x is 1 over cosine x, and cosecant x is 1 over sine x. So we need to apply product rule and chain rule to get a derivative of tangent x, cotangent x, secant x, and cosecant x. And these are the derivatives of these 4 functions. I'm not gonna prove that for you. You can prove that by yourself. Hope this video will be helpful to you. Thanks for watching and have a great day.